Alright, so this is section 6.3, which is on applications involving powers of matrices. So let's look at an example. So let's consider a 3 by 3 matrix. And we want to compute a to the 5th. So which is a multiplied by itself 5 times. Of course, we can directly do it, but it's way too complicated. So we want to use a more clever way to calculate a to the 5th. So let's recall A has a diagonalization. A is equal to P dP inverse. And P is the matrix with column vectors being the eigenvectors. And D is a diagonal matrix with diagonals being the corresponding eigenvalues. Then if you write a to the 5th out directly, a to the 5th is a times a times a times a times a, which is P dP inverse 5 times. And if you write it 5 times, you notice that P and P inverse are together. Then they cancel each other because this is the identity. So these things cancel each other. Alright, so all we have left is just P times D times 5 itself 5 times P inverse. It's P D to the 5th P inverse. We already know what P is. D is the diagonal matrix, so D to the 5th is really easy to calculate. You just have to take the 5th power of the diagonal entry. So this is 243, 32, 32, 0, 0, 0, 0, 0, 0. And P inverse might take a little time but we know how to do this from before, so we do this on scratch paper. So P inverse is 2, negative 2, 1, negative 2, 3, negative 1, negative 1, 1, 0. Alright, so A to the 5th is P times D to the 5th times P inverse. So let's write down what P is. P is this. And D to the 5th is 243, 0, 0, 0, 32, 0, 0, 0, 32, and times P inverse. So 2, negative 2, 1, negative 2, 3, negative 1, negative 1, 1, 0. So instead of multiplying matrices together 5 times, now we only have to multiply 3 matrices together. And let's do the first two first. You should use the calculator. This is equal to 243, 32, 32, negative 32, 243, 32, 0, 243, 0, 64. And the third matrix stays here. And this is equal to, you should use the calculator, 454, negative 422, 211, 422, negative 390, 211, 422, negative 422, 243. So here we go. So this is a faster way to calculate a to the 5th. If you're not convinced, you can raise to a higher power. So this applies to any power. So a to the k is any integer, a to the k is equal to P times D to the kth power times P inverse. So diagonalization gives you an easier way to calculate powers of matrices. Because if k is 100, there's no way you can multiply a by itself 100 times. But it's not hard to calculate d to the 100 because d is the diagonal matrix. So instead of doing multiplication 100 times, all you need to do is doing multiplication 3 times. All right.